Hi, I'm Charlie Culver, Director of the Office of Construction and Engineering. One of the functions of our office is to provide technical and engineering support to OSHA field staff. Over the past few years, we've assisted the field in a variety of enforcement actions, including numerous accident and fatality investigations. We've also conducted several studies into the causes of construction injuries. You may want to look at our initial study, the OSHA Fatality Report, to get a better understanding of the most frequent types of construction-related injuries or fatalities and their causes. The video you're about to see is the first in a series of programs prepared by our office for OSHA compliance staff. The purpose of this series is to provide you, the compliance officer, with technical information to assist you in your inspection of construction sites. Although the video programs will focus on construction, you may find their content applicable to other workplace inspections. Our video series relies on the experience and expertise of national office staff to collect, condense, and present information on a broad range of technical subjects of interest to you. We believe these videos will provide an efficient means for conveying the basic information on the topics covered, but we also recommend self-study and additional training. The subjects we cover in the videos will be those recommended by field compliance staff. The topic for the first video, scaffolds, was selected based on suggestions that compliance officers provided to our office. As scaffolds are used on almost every construction site, it comes as no surprise that this topic was one most frequently recommended for discussion. Although scaffolds are intended to serve as a safe work platform, OSHA data show that during 1985 to 1989, approximately 20% of the construction fatalities due to falls were from scaffolds. Clearly, more attention needs to be focused on scaffolds when inspecting construction sites. And we hope that this video will give you a better understanding of what to look for during such an inspection.
In recent years, more than 50% of OSHA's inspections have been in the construction industry. Since scaffolds are used at most construction sites, OSHA developed this video program to aid compliance officers in conducting inspections. We have consulted with COSHOs from regional and area offices and the scaffolding industry to help ensure that this video will be beneficial. Scaffolds have been in use in some form or other since people began to build structures. It's likely that some form of scaffolding or work platform was used in constructing the pyramids of Egypt, as well as the Great Wall of China. Today, scaffolds continue to be used in almost every type of construction. As far back as 1915, scaffolds caused enough safety problems in the United States to prompt an insurance company to publish a book titled Safety Engineering Applied to Scaffolds on Related Safety Hazards. This publication described scaffolds in use at that time as being badly designed, often constructed with inferior materials, dangerous, and unfit for their intended use. Regrettably, that description is applicable today. In many instances, things have not changed that much. There have been improvements over the years in the design and in the components of scaffolds. As new designs and technology change the work environment, improvements and/or modification of work practices and regulations are required to reflect these changes. And because the scaffold industry is so fluid and the need to keep current so great, the OSHA Scaffold Standard, Subpart L, is presently being updated to reflect some of these changes. This video training pertains to basic scaffold requirements found in the current standard, general provisions of the proposed standard, and some of the critical items to look for during an inspection. Compliance officers should carefully review the new standard when issued to identify any specific technical requirements or changes. Let's take a close-up look at scaffolds, how they are made and used. Since the 1930s, metal has been the preferred material used to construct scaffolds instead of wood. making scaffolds lighter, stronger, and easier to assemble. Despite these improvements, many injuries and fatalities still occur due to improper assembly, disassembly, and use of scaffolds. Considering the wide variety of scaffolds in use and the hazards they pose, it isn't surprising that a recent OSHA study showed that 20% of construction deaths were due to falls from scaffolds or elevated work platforms. Compliance officers must be familiar with the requirements of the standards and pay special attention to scaffolds when inspecting construction sites. To make it easier for compliance officers to target inspections toward the most likely areas of scaffold failure, we will look at how some of the more familiar types of scaffolds should be constructed. Let's first look at the tubular metal frame scaffold, the most popular and widely used type of scaffold found on construction sites today. The tubular welded or fabricated scaffold is a sectional frame type scaffold consisting primarily of end frames and cross braces. Scaffolds must be properly braced by cross bracing to secure the vertical members laterally, and must be of such length as to automatically square and align the vertical members. Proper cross bracing will also ensure that the erected scaffold is plumb, square, and rigid. Scaffold legs are either set on adjustable or plain bases, which are placed on mud sills or other foundations to adequately support the maximum intended load. If built more than one section high, the scaffold frames must be placed one on top of the other with stacking pins to provide proper vertical alignment of the legs. Where uplift may occur due to wind loads or hoisting operations, make sure that the end frames or sections are locked together. When erecting scaffolds, the vertical height must not exceed 4 times the minimum base dimension. If the height exceeds the 4-to-1 ratio, the scaffold must be tied to the building or structure at each end and at intermittent intervals, not to exceed 30 feet horizontally and 26 feet vertically. Outriggers can also be used to broaden the base and stabilize the scaffold. To provide stability and prevent lateral movement, it is a good practice to secure all scaffolds to the building or structure at intervals of 25 to 30 feet horizontally and 25 feet vertically. Drawings and specifications for all frame scaffolds more than 125 feet in height above the base plates must be designed by a registered professional engineer, and copies of the plans made available to the compliance officer for inspection purposes. Since there are several manufacturers of metal frame scaffolds, the mixing of components or individual member pieces is not recommended, but is allowed if the end frames match, the cross members match, and stability and plumbness are maintained. In no case shall there be any modifications made of any components, nor shall they be forced to fit. Another type of scaffold, the tube and coupler, is often used when a work platform is required to be built around an irregular structure. The tube and coupler scaffold usually consists of 2-inch outside diameter steel tubing used to make posts, bearers, runners, and braces. The runners are placed along the length of the scaffold and interlocked to form continuous lengths and connected by coupling devices to each post for stability. The bearers, which help carry the load, are installed across the width between posts and securely coupled to the posts to form a level base for the work platform. Cross bracing is installed across the width of the scaffold at least every 3rd set of posts horizontally. Diagonal bracing is used and installed at approximately a 45-degree angle from near the base of the first outer post upward to the extreme top of the inner post to maintain structural integrity. For stability, the entire scaffold must be tied to and securely braced against the building or structure at intervals not to exceed 30 feet horizontally and 25 feet vertically. Manually propelled mobile tubular welded scaffold, commonly known as the mobile scaffold, is primarily designed for use on level concrete or other smooth floors, to access elevated work areas, or simply to install equipment or parts. Mobile scaffolds, which are supported by casters, must consist of cross braces and diagonal braces secured laterally to the vertical end sections or members to maintain stability. The cross braces and diagonal braces must be of a length that will automatically square and align vertical members so that the erected scaffold is always plumb, square, and rigid. To ensure further stability and reduce the possibility of tipping, the height must not exceed 4 times the least base dimension. For safe access, ladders or stairs must be provided, either built in or attached to the scaffold. Mobile scaffolds are limited in height to a single unit or section unless the entire system is approved in writing by a registered professional engineer, or it is erected in accordance with instructions furnished by the manufacturer. Casters or wheels are attached for mobility. Outriggers, which are also equipped with wheels, can be added for additional stability. Prior to any personnel getting onto a mobile-type scaffold, all wheels must be secured and locked. Casters must be pinned to the scaffold leg or screw jack. Horizontal diagonal braces must be installed at the base, and the work platform must be fully planked. The swinging scaffold, or 2-point suspension scaffold, is a platform not less than 20 inches nor more than 36 inches wide overall. It is supported at each end by metal hangers or frames designed to incorporate guardrails, toe boards, and the hoist mechanism. Swinging scaffolds are suspended from overhead anchorage points by either wire or manila rope, which must be capable of supporting at least 6 times the intended load. Roof irons or other supporting devices, which fit over the edge of a building as anchorage points, must be made of wrought iron, milled steel, or other equivalent material of proper size and design, securely installed and anchored. Tiebacks of 3/4 inch manila rope or equivalent shall serve as a secondary means of anchorage and should be installed whenever possible at right angles to the face of the building and secured to a structurally sound portion of the building. The sheaves of all blocks and the hoisting mechanism must fit the size of rope used. All ropes, wire and fiber, hangers, platforms, and other supporting parts shall be inspected before every installation and every time it is used. 2-point suspension scaffolds must also be securely lashed to the building or structure to prevent them from swaying due to winds or work activity. 2-point suspension scaffolds are designed for a total working load limit of 500 pounds, or a limit of 2 workers on a scaffold at one time. Due to the stress of constant movement by workers, the entire scaffold must be designed and capable of carrying 4 times the rated load. In addition, the supporting ropes or cables must be capable of supporting 6 times the rated load. All hoisting mechanisms must be approved by the underwriter's laboratory or the factory mutual company. Employees working on suspended scaffolds must use a safety belt or preferably a harness with a lanyard attached to an overhead independent lifeline to provide fall protection. This is because the hoisting mechanism or supporting devices could fail. Now, there are a number of things a compliance officer should be looking for when inspecting scaffolds. In addition to checking for the stability of a scaffold, check for any damage to component sections, individual members, planks, or accessory items. Manufacturers rate scaffolds to support 4 times the maximum intended load. Because of the complexities of scaffold erection and the multitude of configurations possible, maximum loads for scaffolds are normally determined by engineering calculations. During the initial inspection, look for signs of distortion or bent members when considering weight limitations on scaffolds. For example, ANSI limits plank deflection under a load to 1/60th of the length of the span. In other words, a 10-foot span is limited to 2 inches of deflection, which can be measured with a tape measure and a straight edge. Also note whether an access ladder or equivalent means of safely getting onto and off of a scaffold is provided. Ideally, scaffold planks should be metal, usually aluminum. When wood is used, however, the planks must be scaffold grade or the equivalent. That means the specific classifications of strength as determined by either the West Coast Lumber Inspection Bureau or the Southern Pine Inspection Bureau. The classifications are marked on each plank. All planking and platform sections must be overlapped a minimum of 12 inches or be secured from movement. Additionally, when cleated or otherwise secured, planking must extend at least 6 inches over the scaffold end supports or bearers to ensure that it does not slip off in use. The planking must not extend more than 18 inches beyond the supports unless barricaded. In review, accident data tell us that the most important item to inspect on any scaffold is the fall protection system and the stability of the structure. Falls are by far the leading cause of scaffold fatalities. Since scaffolds are elevated work platforms, all components contribute to fall prevention. When inspecting a scaffold operation, you should check for support under each leg in every frame. Make sure that all base plates are in firm contact with supports. Inspect frames for plumbness. Check frames for gaps and misalignment of adjustment screws. Make sure that all end frames have cross braces to ensure stability and plumbness of units. Inspect locking devices, making sure they're tight, and check all planking for proper installation. Make sure anchors are secure between scaffold and structure where required. Verify that all guardrails are in place and secured. Inspect motors on all power-driven scaffolds for proper operation and certification. Check ropes on all suspension scaffolds for proper size and for signs of wear or deterioration. We have looked at many of the scaffolds covered in the OSHA standards, highlighted the basic safety requirements, and identified some of the more critical items that you should check when inspecting scaffolds. As a compliance officer, your familiarity with the standards, coupled with a careful inspection of scaffolds found at the worksite, will contribute to reducing the large number of accidents and deaths due to falls from these elevations.
I mentioned in the introduction that we plan to produce a series of videos. Now that you've viewed the first program, we need your comments. Your feedback will help us determine if the information is useful and if you want us to produce similar programs on other topics of interest to you. Please write, fax, or call in your comments to our office at the address on the screen. We welcome your comments and thank you for your participation.